My name is Nick, and I work at Movil. We're building basically mobility service integrations for public transportation cities, and then we have like white label solutions and offering integrations for My Taxi, Car2Go, public transport, and others. And today I'm going to be talking about Kotlin on code quality tools. So I'm basically elaborating what tools are available, how you can use them, what benefits they are, what they have, and also how you can extend them. So let's first go and start off with the motivation, like why you want to go and use code quality tools on your code. So probably everyone has seen classes like this. It has like too many methods, and this is something that a tool can easily go and detect. It's also for things that are complex methods. So if you have like a lot of branches, a lot of if statements, a lot of return statements, or like a lot of parameters, those tools, they're like much quicker at detecting this. They can go and run on like every pull request, and it's just something that we as developers, we don't need to go and spend time reviewing this. And instead we can like focus on architecture, on like how the parts are working together, how they're like coupled together, and the easy things that can be done by tools. So another example is something like this. So this class formatting is like completely off. Everything is like on its own line. And ideally you should go and look something like this. And this is also something that tools can go and do for us. So we don't want to go and do this all by hand. Instead, we want to go and be running a certain tool that does the job for us. Another case is this function. I'm going to go and have you had a little look? And then here, have you seen the difference? So basically, the variable was unused. So this is something that can easily be caught by static analyze tools, and it goes even further by looking at methods that are not used, classes, parameters, and the less things we have, the less things we need to maintain, so we should be striving for not having unnecessary things. Another example is this one. So depending on the language, uppercase and lowercase letters are different. So you want to be explicit about the locale. So what you ideally want is to go and pass the locale. So if you're printing something out as like a debug, usually you want to go and have like the US one or like the user default. And so those tools can also go and have a look at certain APIs that you're using, and then making sure that you're using the version that is the one that should be used, and not like relying on like implicit defaults. Another case is this one. So we have like a public interface, and ideally, since it's public, it should also go and have documentation. So this is also something that tools can go and have a look at. And since documentation is also like a sentence, it should be written as like a sentence with like a dot. This also be something that can be automated. Another case is this one. So we are using Kotlin, and we're using Kotlin 1.3, but actually this is no longer the latest version. So tools can also go and have a look at are there new dependency updates, in which case there's Kotlin 1.3.10. Another example is like a simple class that only holds two values. It can be a data class. And another case is this toHuman readable ASCII method. That's we're basically using, but it turns out this is inside an internal package from a Java file. So ideally, we shouldn't be using this because it's subject to changes, and it can go and break us. So this is also something that tools can go and help us. So what tools are there for us to go and ease our life? So there's Android Lint, there's Detekt, and Lint. They all go and work on Kotlin. So they're all supporting Kotlin, and Android Lint also supports Java. They all, what they end up doing is like generating a binary. So you can invoke the binary, you can specify some of the configuration parameters like the inputs, configuration, whether you want to go and exclude something. So you can also run them on like CI. So you don't need to like have a specific integration because it can be invoked from the normal terminal. Also configuration, all of those tools, they have a configuration. Lint is a bit limited in a way that like it's relying on the Kotlin and the Android styling guidelines. So it's enforcing those, and then you can go and tweak some of the parameters. And Android Lint and Detekt has lots of configuration you can go and have. Static analysis, so like looking at complexity, looking at things, that's mostly done by Android Lint and Detekt. Lint has the capability, but it's more focusing on formatting. So you can think of it like Android Lint and Detekt, they're focusing on static analyzing, and Lint is more looking at formatting. And another big part that is really cool is autocorrection. So if a tool knows that there's something wrong, it's even better if the tool can go and fix it for yourself. So you don't need to like spend time trying to go and fix it yourself. Android Lint has an integration for that. Detekt does not currently. And Lint also has an option to go and format all of your files. So reporting, once you run those tools, you also want to go and see, okay, what has been reported. They all support that between HTML, text, and XML reports. And then another cool feature is baseline. So baseline is basically, if you have not been using those tools and you start on like your project, usually they go and find like some warnings, some errors. But you don't want to go and spend like 1 week trying to fix all of these. So what baseline allows you is it allows you to like make a baseline of all of your warnings and all of your errors. And then basically, if you run the tool again, it's telling you, okay, it's succeeding, but it's filtering out those warnings and errors earlier. So you can like start integrating those tools, and then you can start using them. And only your new code is then gonna go and get analyzed by those tools. So you can like go and start making them fail. You generate a baseline file, and then the new code that you add, it's gonna be inspected, and then hopefully slowly, time by time, you're gonna be able to remove the baseline file. So let's go and have a look at Android Lint. If you're just using the normal Android Cradle plugin, Lint is coming out of the box for you. You don't need to go and add anything. However, if you're using a normal Kotlin module, you can also go and add the com Android Lint plugin. So this one is capable of running Lint also on Kotlin-only projects, which is quite handy. So you can basically run Lint everywhere, also on Java projects. And then if we go and run it, it looks like this. So we run Lint, and it says, okay, we have nothing like found in your project. We generated the HTML and XML report. And then if we, let's say, run Lint on this particular Cradle file with like the old dependency, we can see, okay, Lint is telling us, okay, there's like a new version available, which is pretty cool. And then it's also telling us in the command line, like the last 3 or 5 issues, we can go and have a look at them. And then if we like run this on the CI, we can also use like the HTML and XML report for that. HTML report looks like this. So all of your issues are listed there, and then there's like a preview. So you can look what is being flagged. XML report, the content of it is like not really that important. Usually you go and hook it up into plugins. So like on Jenkins, there's an Android Lint plugin, and then you like pass in the XML file, and then you get like a nice report and like stats. Lint configuration can be done by the Lint options. If you're running in like an Android module, you wrap it inside the Android closure, and then you have like a bunch of things you can go and configure. So the Lint config is an XML file. I'm gonna go show next. Then each issue has like an ID, so there's like typograph codes, and then you can like say whether you want to enable them, disable them, whether it should be a warning, fatal error, just an error, whether you want to go and ignore it. And then you also can like tweak certain severity levels. So, or like you can say all warnings should be errors. You can say that also the issues that are disabled by default, you want to go and run them. There's basically like a bunch of options where you can go and tweak it to your needs. The XML file, the configuration file looks like this. So you can, for instance, say that some of the, like for unused resources, we want to go and exclude a certain thing with like a regex. We can also go and say that an entire issue ID should be ignored, and we can also say, for instance, instead of ignore, we could be writing fatal. So if you're like building a release version with assemble release or with Android Studio, and this is like marked as fatal, the Lint is actually running those fatal Lint checks for you and then breaking the build if it finds something, which is also super helpful. And then there's also like a path option where we can go and exclude certain things. Now for the baseline, there's also the baseline function that we can go and use. And then we basically specify a file that's being used. And then if we go again back and look at the code with the old dependency, and if we go and run our Lint task, basically it scans the entire project, looks at everything, and then it's telling you, okay, hey, we found this error, we're creating this baseline file for you, and we're aborting the build, in case this was like not intentionally invoked. So the baseline file looks like this. It's pretty similar to the XML report, so we see like the issue ID, which part of the code has been flagged, and the location. And this file then you start and commit it into your repository, so like in your Git control system. And then with time, hopefully this file is gonna go and get smaller and smaller. And then you can go and basically start using Lint. You can enforce everything, and your old code is not going to be stopping Lint from executing. Because the moment like Lint finds something, an error, it's aborting the build. You don't want to go and have that. And then if we go and run Lint again, it's telling us, hey, okay, this build is successful. However, one of the errors is filtered out by the baseline file, which is what we want. Even better is if we do all of this and then we open the Android Studio IDE, we still get support for it. So it's still like making this line yellow and telling us, okay, there's something wrong with it. And then if we alt enter into it, it's telling us, okay, hey, there's this newer version, we can like quick fix it. So if we press enter, we can change it to 1.3. And if we want to, we can also suppress this. Now this is like helpful if you're always in your IDE, but ideally you also want to go and make those fixes from the terminal. So starting with like Android Cradle plugin 3.2, they also added a new task for that. So the task is called Lint fix, and it basically takes your project, scans everything, and it's applying the fixes for you. So the Lint checks, they need to go and opt into that, and they basically need to go and provide like a quick fix, it's called. So telling us, okay, this is something that's not correct, but we can autocorrect it, and it's safe to go and autocorrect. And then if we go and look at the git diff, we can go and see these changes. So one example is that in Java and Kotlin, sometimes there are those synthetic accessor methods, like if something is private but you're accessing it, then Java will go and generate like a package private function in order to go and exit that private one. But the fix for that is just to go and make it package private. And also Lint has a check for that, and I've been activating that at work for us, and then instead of fixing like one for one each of those cases, you can just go and run a Lint fix, and it's like fixing everything for you. And it's the same for other Lint checks for like the content description on image views, or like the base alignment for linear layouts. It can go and add those itself. Now let's go and have a look at Detekt. Detekt, this one I'm going to set up on my own, so I need the repository. Then I'm creating a new configuration for Detekt, because I don't want to go and have it on the same class path as our normal dependency, so it's not being bundled into the APK. And then I add the command line interface, basically the jar is a dependency. And then creating the Detekt task, we basically use the Cradle syntax for that. So it's a Java execution task. We go and specify the main class. For class path, we're saying, okay, we're using the CLI, which comes with the normal default checks. And then for arguments, we can pass in a config file. We can say like where we want to go and run it. So what's the input? So we take the current directory and what kind of reports we want to go and have. So in this case, it's XML, HTML, and text. The configuration file looks like this. So it's a YAML configuration file. Failfast is, the name is a bit misleading, but what it does is it takes all of the default rules, or like all of the rules, and it enables all of them. Because some of the rules that are being shipped by Detekt, they're not on by default. But this way you can like turn everything on, and then you can tweak things that you want. So the max line length rule, for instance, in the style category, if you want to go and have like a different maximum line length, you can go and specify that. So like you get all of the defaults, you turn everything on, and then you like can selectively tweak what you want to go and have or not. And if you want to go and disable a rule, you can just say active false. So now if we go and take this class that we had earlier, and if we go and run Detekt over it, you can see that there's the second inspection is like too many functions. So it's like one of the rules, another one is like end of sentence format, which is like if you have like documentation and it's not like ending with a dot, it probably should. And then there's also other things like unused private members, so things that we don't need, or like use data class where we have classes, but they are not using the data feature. Detekt also has something that's called depth. So each rule comes with like a estimation of how long it probably takes to go and fix this. So at the end, it's like aggregating all of the values and telling us, okay, for this case, it would be like an hour to go and fix it more or less. And then it also spits out a lot of useful stats, like how many lines of code, how many properties, packages, like the complexity of certain things. HTML report doesn't look fancy, but it does the job. And then XML report, the content also of that is not really necessary. But the important part is that the content here is complying with the Checkstyle format. So we can use the Checkstyle, which is a static code analyze tool for Java, to go and read that report. So there's like a Jenkins plugin, for instance, for that, and then we can go and feed that XML report in. So it doesn't need to have like a specific Detekt plugin or like a Lint plugin. They are relying on the Checkstyle format, which is also good. Lint. The ceremony is pretty much the same. We have a repository, we create a new Lint configuration, and then we add the Lint dependency. And then there's also the tasks that we can go and add, so like Java execution. We pass in the main file, the class path, and the arguments. So in this case, we want to have a plain reporter and a checkstyle. And then we like pass in all of the files like source, wildcard, star, all of the Kotlin files. The configuration file, it's using the editor config mechanism. So we can specify what the intent size is and the continuation intent size, max line length, and whether we want to go and have a new line at the end of the file or not. And this is more or less like all of the configurations that you have. So everything else, like whether parameters should be like on one line or like on multiple lines, that's all being taken from the defaults from the Kotlin and Android style guidelines. So if we go and have a look at that class, and then we go and basically run Lint, we can go and see like, okay, this colon is not on its right place, the parentheses is also wrong. And then XML report again is also using the Checkstyle format, so we can also go and feed that into normal Checkstyle plugins. But since Lint knows like what's wrong, it's even better if it provides like auto formatting, in which case it does. So if we just pass this -f parameter, and then if we go and run it again, so we say Lint format our task that we created, and then if we do a git diff, we can see like it's formatting pretty closely. So like it's putting all of the parameters on its own line. They have like the right indentation. The spaces between like the colon and the parentheses are removed, and just everything is being put nicely together. How would you go and expect it? So the best way to go and add Lint is just edit, format your entire code base once to like the standard, commit it, and then you can go and move on. So now all of this is cool, but usually if you start dipping your feet into that, you also want to go and add custom rules. So you want like specific custom behavior. So one that I want to go and show is basically a class which is importing an internal class in an internal package. So we have the internal import class, which is using the internal class, which is an internal package. So if we go and think about how the tools have or like see the classes. So what, for instance, Lint is using UAST, it's Universal Abstract Syntax Tree. There's also just AST, and the difference between UAST and AST is that AST is usually like specific to a language like Kotlin or Java. And UAST is being developed by JetBrains, and they basically have a universal syntax tree, and that way they are supporting Kotlin and Java. So you can operate on that universal one, and then you get like out of the box support for multiple languages, and you don't need like custom rules for specific languages. And then if we basically take that class from above and we feed it into like a tree, you can see that it starts with like a file. There's no package name because I didn't declare that. And then it has the file has like children, so we're like traversing down that tree. So the first one is like the import statement. Then we go and start with the class. Since this is Kotlin, in the end it generates to like a Java bytecode class which has like a field, a constructor, and a get method. So that's why you see like more things in the UAST. So there's like the field, that's the field from the internal class variable. Then it's like annotated with like not null, and then if you want to go and flag something, it's usually best to go and look at your use cases, get like the tree, there are like debug methods for that, and then you like can go and visit those methods. So those tools, they use the visitor pattern, and then you can visit each of those elements. So for instance, you can visit the import statement, you can visit the class, you can visit fields, you can visit annotations, and then what you end up doing is you start aggregating all of the data that you need, and then you're like, depending on your check, you're checking, okay, what is it that I need to check against? And then I can just go and report warnings. So how does it look like in Android Lint? So we need to go and create a new module. It's a Kotlin module. We need the repositories for retrieving the dependencies. And then dependencies are Lint API. And then for testing, they also have special testing support. And then the first thing we start doing is we create an issue. We give it a name, that's a no internal import. Then like a brief description, no internal imports, and then like an explanation. So we don't want to go and import something from an internal package because they're subject to change. It's in the category correctness, priority, I just gave it a 10. It's a warning, and then implementation is where we start implementing it. So it's using something that's called detector, and then we basically say this detector can run on Java file and test sources. Java file, the name doesn't imply that it's only for Java, it's also for Kotlin. It's just that with Android Studio 3.0 and Cradle plugin, they added Kotlin support, and this hasn't gotten a rename yet, but it's supporting both Kotlin and Java. So the detector, we basically extend from the detector class, and we're telling it, okay, we're also implementing the UAST scanner, and then we start saying, okay, what are the types that we're interested in? And if you remember earlier, the import statement, it was a U-import statement. So we're saying, okay, the applicable types that we are interested in is a U-import statement. And then we go and create something that's called a UAST handler. And the UAST handler looks like this. So we have this visitor methods from the visitor design pattern, and then basically we can override the visit import statement. We go and get the import statement. So what Lint does is it looks at all of the files, looks at all of the imports, and then it's basically looking what detectors are there, which types are they interested in. If they're interested in an import statement, they can go and call the import handler, and then they call the visit import statement. So for every import statement, this method is going to be called. Then we get the import reference, we take the source string, and then if it's containing the internal package, then we can basically say, okay, this is an issue, we want to report it. We pass the issue, the node, the location, which is where like the scribbly lines and the yellow and red warnings are, and then we have like a normal message that we can go and pass. So this is like everything that needs to be done for just creating your own rule. The part that's missing now is Lint needs to go know how to go and find this detector. So what mechanism they have in place for that is called an issue registry. And there you basically go and override like the issues property, and then you like pass the issue that we created earlier. And then we can also say to which Lint API we're compatible. For that, we're just using current API. And then the final last place is to go and add a manifest attribute with like the fully qualified name of that issue registry. So what Lint can go and do then is it can go and look at the jar, looks at the attribute if it's set, instantiate our class, it casts it to our issue registry. From the issue registry, it could go and look at the issues, and then it had basically access to everything it needs. So that's like the way we can go and add Android Lint issue registry. And then testing is also super easy. They have like their own DSL kind of fluent API for that. So we can call a lint method. We pass in files. They're just normal text files. Then we say which issues we want to be running against, and then we can say run expect. And then here in the expect statement, you basically get all of the information that you want. So we can see it's a warning. We can get the text. We get the issue ID, no internal import. And then we also get like a preview of what would be flagged. So in this case, the import statement on its own, which is the location. And since this is operating on UAST, we can also go and quickly write like a Java test. So also ensuring that this works on Java. So the only changes that we need to do is like instead of KT, we write that's a Java file, we add the semicolons, which are required. And then the assertion is more or less the same. It's a Java file instead of Kotlin. But since it's operating on UAST, it's super handy. So if we have like a code base that's mixed between Kotlin and Android, I would suggest to go and use Android Lint. So the only thing that's missing now is adding your custom rule to your project. So if you're in your app, you have dependencies, and then the Android Lint plugin is adding a custom configuration called Lint check for that. And then you basically go and specify the path from the project. Also, there are open source repositories like Timber and Butterknife. They also ship their own Lint rules, and it also works. It's like either you can say Lint check, just like a normal project there, or you can also use like implementation API with like a custom Android AAR file, and that can also go and bundle Lint checks. So if you just add Timber to your project, for instance, or Butterknife, the custom Lint checks are also added. Now, if we go and run this on a project, we can also go and see, yeah, we're importing this internal class. Now good, should be fixed. And This currently only works for Android-only projects. So for Kotlin projects, the adding your custom rules does not work, but there's an open issue for that. And that was it about Android Lint. So Detekt, it's again, we need to go and create a module again for our Detekt rules, the repositories, and then also the APIs that they're providing. So like the Detekt API, and then they also have special testing API. Then we create our rule. We don't need any configuration in this case, so we just take config empty, and then we subclass from rule, pass the config, and then here we override an issue, we give it a name, it's a maintainability, and just a normal like message, and the depth value, like how long it should take to go and fix it. And then also here we have this visit pattern that we can basically go and say, okay, we have this visit method. This time it's taking a KT input directive. That's the class that's coming from the Kotlin compiler. So this will only go and work with Kotlin code. But the parts of the methods are pretty much the same. We take the import path as a string. We check if it's containing internal. In case it does, we report it as a code smell, and then we pass in like a custom message. Also here, we need some mechanism for letting Detekt know that this is something that, or like those are the rules that I have. So we provide a rule set ID. This time it's Detekt custom rules. We pass in the instance, basically a rule set. So we give the ID and also a list of all of the rules. And this class also needs to be picked up somehow by Detekt. And the way it's doing that is by using the service mechanism. So we, in the resources in the meta-inf, we basically create a file called io-gitlab artopush detect API rule set provider. And Detekt is looking for that class, and then the content of that is the fully qualified name of our rule set provider. So the way Detekt looks it up is it's looking at the jar, looking, okay, are there any custom services? If so, do they match the name of Detekt? Then it's looking at the content, and then it can go instantiate that class again, cast it to a rule set provider, get the rules, run them. Testing, also super quick here. We go instantiate the rule. There's an extension method provided by the testing dependency to go and lint your code. Then we can say, okay, this should be one finding, and the finding should be that we're importing a internal foo. Then adding that to your project is also straightforward. So again, we can go and use the configuration detect, and then we add the project, and then we can go and run it. And then you can see here that the third flag is basically no internal import rule, and so it works. So we can go and add it to our project. KT-lint is also similar here. We need, again, a new custom module, repository, we take the APIs. Then also they have like a rule, their own rule, which we go and give like a identifier. Here it's a bit different, so instead of having like a specific visit method for each of the capabilities like classes, annotations, methods, input statements, it has one general one. So what we go and do is we check if the element type is of the import directive, and again here, if that's the case, we can cast it. So it's also using the classes from the Kotlin compiler. So also this will only work with Kotlin. Then again here, the next part is basically the same. We take the import path again, and then if it contains internal, we can go and emit a warning. And then also, somehow by coincidence, it also has a rule set provider, the same name, as a get method. So we pass in the rule set, give it a name, and then also the instantiation of our custom rule. And the mechanism for loading that class is also the same. So it's also using the services mechanism and providing the fully qualified name of our custom rule set provider. And then again, it's like hooking up it the same way that Detekt does. So testing that, also super simple. We can instantiate the rule. We can lint it. Same again, we pass the Kotlin file as string. And then we can say, okay, there should be one lint error on the second line at offset 1, importing a internal foo, which is an internal import. So also that's like super easy and straightforward. Extending KT-lint is like adding it to your own project is again super similar. So we say, okay, KT-lint, and then the project, we take our custom KT-lint rules. And then if we go and run KT-lint on our project again, we can go and see that here the second last one is, okay, we're importing the internal class, cannot be autocorrected since we didn't go and provide any autocorrection for that. Now that was like a lot of information for like every tool, how you can use them, how you can extend them. Now I want to go and share some more resources. So for Android Lint, you can contribute on the Android open source project, source Android.com. Then there's also a Google dev community, which is super helpful, the Lint dev. Also the maintainers from the Lint, Matthew, he joined recently, and Tor are active there. So also any questions can be asked there, they're super helpful. Then there's the issue tracker. So if you find anything with Lint, and you will find a lot of things that are not working correctly or not optimal, you can also go and report it there. And they're like super quick at fixing it. The only drawback is that you usually have to go and use the alpha versions of like Android Cradle 3.4. I also gave like an in-depth talk a bit more about Android Lint a while ago, wrote an article. I also have my own custom Lint rules. And what has really helped me writing or like dipping my feet into writing those own rules is looking at the ones that are present. So all of the rules that we have from Android Lint that are coming by default, which are like, I think 350, they're all open source. You can go and have a look at them. And then if you have like something which you want to go and write a rule for, and you know that's something like similar. So for instance, if you want to go and write like an inspection for layout files, you can go and, for instance, look at the label for lint check, which checks that Detekt has like a label. And then if you want to see how it works, you can just go open the link, look at the detector. They're also all covered with tests, so it's like really nice to go and get into. And then you can also look at the more complex ones. So for instance, there's like the check result lint check that checks if you call a method that's annotated with check result or like check return value, and that value is not used on the callee side, it will go and be flagged. So this is like something that's rather complex to go and do, but all of those rules are open source, and you can just go and have a look at them. Detekt, the Android is on, the project is on GitHub. It's open source. Also in the Kotlin language Slack, there's a Detekt channel, which is also pretty active. Also wrote about that, writing your own Detekt rule. And for Lint, there's no Slack channel as far as I know, but it's also open source. Now, another thing, like you might be wondering, okay, this is like a lot of things that needs to be configured, needs to be added. So I also have a code quality tool for plugin, which adds not only Android Lint, Lint, and Detekt, but also static code analyze tools for Java, so like Checkstyle, PMD, Findbugs, Error-Prone. So you can go and check that out. And then also everything that I've shown here, all of the code, I've also put into the Kotlin on Code Quality Tools GitHub project. So like all of the custom lint rules, how you can go and configure them, how you can go and extend them, all of the modules, everything you saw on the slides here is also there. The tool for adding all of the tools for your Android app is below, and you can reach me on social media there. So thank you. Are there any questions? Okay, so the question was about performance. How did you go and compare? Lint and Detekt are super fast because they don't go and compile the code. So they take the code, they convert it into the syntax tree, and then they run on it. Android Lint is a lot slower because it's compiling code, and it's also offering something that's called type resolution. So let's say you have a class and a field, and the field has a certain type. In Lint and Detekt, you can't go and get access to that type and look like what are the methods. And Lint has a way for that, but in order to go and resolve that, it needs to like go and do a mapping and do also some computation before. So Android Lint is a lot slower than Detekt and Lint. Okay, so the question was whether Detekt is helpful and whether it's helping writing better code. One thing that I really like is you can still like configure like, let's say how many methods a certain class has, but what's really helpful is it's just like a little knock knock, like, hey, this is something that I found, this method is like complex, it has like a lot of return statements, and usually that is like enough of a trigger to go and think about whether it can be done or like written in a smarter or easier way. And then if there is like, there are certain things which are just complex, so they can be ignored, but for like most of the cases, also on our team, in the beginning they were like hesitant, okay, this is like flagging so many things, but in the end it turned out to be good, because you like get a report, you say, okay, this could be like improved, and then you start thinking about it again, and then usually if you have like a break, let's say like 4 hours between them, you think about it again and usually come up with like a better solution. So I'm thinking it really helps a lot, yeah. Okay, so the question was whether there's a value in combination all of them, and like using all of them. We are using all of them at work. I still like to think that every project has its own like feature set. So Lint is like solely focusing on formatting. Detekt is focusing on like complexity, how your code is organized. And Android Lint, the default rules, they're more focused on like Android specific things. So in my opinion, they're all contemplating each other because each is like focusing on a certain thing. However, if you want to go and write your own rules, I would still stick to Lint because the API is a lot nicer. It has a lot of functionality. And Lint also has the capability to not only look at Java and Kotlin files, you can also look at ProGuard files, you can look at images, you can look at the Cradle files. So like everything that you use as a daily Android developer, you can go and look at and inspect, which is not the case for Detekt and Lint. So the question was baseline support for the tools. Lint does not offer baseline because you can just let the auto formation run once and then there are no other issues that are being flagged usually. So like you can format your code base once and then you don't need the baseline. Android Lint has baseline like as shown, and for Detekt they also have baseline. So they have like a -- create baseline argument that's generating the baseline, and then it also has a baseline argument for specifying the file. Then I would go with Detekt. So if performance is something, but although I would still recommend you to run Android Lint, and the slow part about Android Lint is like compilation and the mapping and everything. The running your own rules is not that like time consuming. So if you're running the normal Android Lint and you add like 5 more checks to that, the performance is not going to be way worse. Maybe like 2-3 seconds, but you're paying that initial time. So, but if you really like, if you don't use Android Lint and you want to focus on performance, I would go with Detekt. Yeah. Okay, cool. Then thank you, and I'll be here around for other questions.